Hello everyone, I'm Samantha Nicole D. Fernandez, and I am here to present and help you to learn about a topic in data management that what we call analysis of variance, or what we call ANOVA. Analysis of variance, or ANOVA, is an analysis tool used in statistics that splits an observed aggregate variability found inside a dataset into two parts, which are the systematic factors and the random factors. The systematic factors have a statistical influence on the given dataset, while the random factors do not. Analysts use the ANOVA test to determine the influence that independent variables have on the dependent variable in a regression study. The T and the Z-test methods developed in the 20th century were used for statistical analysis until 1918. It is when Ronald Fisher created the analysis of variance method. ANOVA is also called the Fisher analysis of variance, and it is the extension of the T and the Z tests. The term became well known in 1925 after appearing in Fisher's book entitled Statistical Methods for Research Workers. It was employed in experimental psychology and later expanded to subjects that were more complex. The formula for our ANOVA is F is equals to MST over MSE, where our F is the ANOVA coefficient, our MST means the mean sum of squares due to treatment, and our MSE means that mean sum of squares due to error. The ANOVA test allows a comparison of more than two groups at the same time to determine whether a relationship exists between them. The result of the ANOVA formula, the F statistic, or what we call the F ratio, allows that the analysis of multiple groups of data to determine the variability between samples and within samples. There are three types of ANOVA: the one-way ANOVA, the two-way ANOVA, and the three-way ANOVA. Let's start first with our one-way ANOVA. One-way ANOVA, or one-factor ANOVA, evaluates the impact of a sole factor on a sole response variable. It determines whether all the samples are the same. The one-way ANOVA is used to determine whether there are any statistically significant differences between the means of three or more independent groups. For example, 15 students at Marcos University were selected for an experiment finding what ideal temperature to take an examination. There are 5 students each in cold temperature with 15 degrees, normal temperature with 25 degrees, and warm temperature with 35 degrees were randomly selected. The students were given a 10-item test. Is there or no difference exists between the three different degrees of room temperature? So that is our example, in which we need to find if there are difference that exists between the three different degrees of room temperature. So we have now our data: the cold, the normal, and the warm, in which ANOVA, or a one-way ANOVA, this means that we have a one factor, and this is the temperature of the room or the classroom we have or given. First, we need to find our hypothesis, which our null hypothesis means that our population 1 is equals to our population 2 and equals to our population 3. In this case, we have cold that is equal to our normal and equal to warm. This means that there's no real difference exists between the tested groups, while our alternative hypothesis means that at least one group is different from another. Let's go back to our data here and find our mean. Let's find our mean first. In finding our mean, we need to add the data given in one column divided by how many are there in the column. So in 15 degrees, we have 4 plus 7 plus 5 plus 3 plus 5 divided by 5. We have 4.8 as our mean. first mean, and then in our 25 degrees column, we have 8 plus 6 plus 7 plus 6 plus 5 divided by 5. We have 6.4 as our second mean. And in 35 degrees, we have 2 plus 2 plus 3 plus 4 plus 5 plus 1 divided by 5. And we have 2.4 as our third mean. Next, we find our sum of squares, where our formula is the summation of x minus x, our mean, to the second power. So, we have here 4 as our first data given. So, in finding our x minus mean to the second power, we have 4 minus 4.8 as our mean is equals to negative 0.8, and square this, and we have 0.64. So we do this in every row, and we have our x minus the mean to the second power. We also do this in the second column of our given, in which it has a 6.4 mean. So in this case, we have 8 minus 6.4 and squared it and have 2.56. In here, we have 2 minus 2.4 and squared, we have 0.16. Then, in order to find the sum of squares, we need to sum this all given stated that we calculated. So we have 0.64 plus 4.84 plus 0.04 plus 3.24 plus 0.04. Now we have our sum of squares, our first sum of squares, that is equals to 8.8. Next, we have here 2.56, 0.16 plus 0.36 plus 0.16 plus 1.96. We have our second sum of squares, 5.2. In here, we have 0.16 plus 0.16 plus 0.36 plus 2.56 plus 1.96, and we have our third sum of squares, which is 5.2. So we also have column here for our x squared, because we will be needing this in our next equations. So 4 squared is equals to 16, 7 squared 49, 5 squared is equals to 25, 3 squared is equals to 9, 5 squared is equals to 25. So we also need to add this to have our summation, because we'll be needing this later. So same as here and same here. So other than that, we need to find our k, our n, big letter N, and the summation of our x, and our summation of x squared. So our k means the number of treatment conditions. So we have 3. We have the 15 degrees, the 25 degrees, and 35 degrees. So we have 3. And our n, the number of scores in each treatment, which are these. We have 5. In each column, we have 5. And our n, the total number of scores, where we have 5 here, plus 5 here, plus 5 here. So in total, we have 15. So our summation of all scores in the study, so we have to add all the summation of our studies, which is this one, and this one, and this one. So we have to add all of this. 4 plus 7 plus 5 plus 3 plus 5, we have 24. Same here in our second column, and same here. So we have 24 plus 32 plus 12, we have 68 as our sum of all scores in the study. While our sum of our x squared, which means the sum of all squared of scores in the study, we need to add its x squared, so this one. So 124 plus 210 plus 34, now we have 368 as our summation of x squared. Next, we have our ANOVA table for one way. We have the source, our sum of squares, the DF, MS, and F. So in our source, we have the between treatments, the within treatments, and our total. Find our sum of squares of total using the formula SS total is equals to summation of x squared minus summation of x to the second power over n. So since we have our data earlier, now we can answer this, in which our summation of x squared is 368. This one minus our summation of x 68, and then square this to the n, which is our n is 15. So 368 minus 68 squared over 15, you have 368 minus 4624 divided by 15, and we have 308.27. So 368 minus 308.27, we have our summation of squares of total is equals to 59.73. So now we have our sum of squares total. Next, let's find our within treatments. So in finding our sum of squares within treatments, we use the formula SS within, or sum of squares within, is equals to summation of sum of squares inside each treatment. So we need to add the three sum of squares. So this one, 8.8 plus 5.2 plus 5.2. So this one, add them, and now we have our SS within 19.2. Next, we need to find our sum of squares between treatments using the formula SS between is equals to SS total minus SS within. So we need to this summation of squares total minus our SS within or treatments. So we have 59.73 minus 19.2. We have our SS between equals to 40.53. Next, we have our degrees of freedom. So in order to find our degrees of freedom, we need to do this. This is our equations or our formula. So in our degrees of freedom total, we have n minus 1. So since our n is 15 minus 1, we have our df total equals to 14. In our df within, we have n minus k. So our k earlier is the categories. So we have 3. So n minus k is equals to 15 minus 3 minus is equals to 12. And our df between is k minus 1. So our k is 3. So 3 minus 1 is equals to 2. So now we have our degrees of freedom. Next, let's solve our mean of squares, or MS. So our mean of squares in between is simple. We have the formula MS between is equals to SS between divided by its df. So we have 40.53 divided by 2. So 40.53 divided by 2, we have MS between is equals to 20.27. In our MS between, we also have the same formula in which we divide its sum of squares to its degree of freedom. So SS within divided by the DF within, we have 19.2 divided by 12. We have 1.6 as our MS. Next, let's find our F ratio. F ratio, or the F ratio statistics. F is equals to MST over MSE. It was mentioned earlier that this is our formula. So F is equals to 20.27 divided by 1.6, because our MST or our measure of mean of sum of our treatments is 20.27 divided by our errors or within the treatments 1.6. So we have 12.67 as our F ratio. After finding our F ratio, next we find the tabular value of F, in which we need to find the denominator, DF denominator, and the DF numerator. So our DF denominator is our within treatments. So our DF now is 12. The DF numerator is between treatments, which is 2. So let's find this in our table F, or tabular value of F. So 2 as a numerator and denominator is 12. So we have this one, 3.89. Now let's compare the F ratio statistic, our computed value, to the F critical value of our table F. So since our F ratio statistic is 12.67 and our F is into 12, the 3.89, let's compare these two. Now, as you can see, 12 is greater than our F critical. It is said that, however, if our F ratio statistic is greater than the table F, we reject the null hypothesis. So as this one, as F cal is greater than our F crit, we reject HO, or null hypothesis. Therefore, there's a significant difference between the exam scores and the three groups. So that is our first problem. Next, another example. 21 students at Autonomous University of Madrid, or AUM, in Spain were selected for an informal study about student study skills. 7 first year, 7 second year, and 7 third year undergraduates were randomly selected. The students were given a study skills assessment having a maximum score of 100. As researchers, we are interested in whether or not a difference exists somewhere between the three different year levels. So in this one, we have a one factor, which is the year level. It is categorized with 3 year 1 scores, year 2 scores, and year 3 scores. Next, let's find our hypothesis, which is our year 1 equals to our year 2 and equals to year 3. This means that there's no real difference exists between the tested groups. Our alternative hypothesis is at least one group is different from another. Going back to our data, we now have our mean of our year 1 scores. We just need to add this all. And now we have our divided by, how many are there? 7. 1, 2, 3, 4, 5, 6, 7. So add, divided by 7, we have 71.71 as our first mean. Add this all, and divided by 7, we have the second mean, 72.29. Add this all and divided by 7, we have the third mean, 4.8. Now that we find our mean, let's go and find our sum of squares, wherefore our formula is summation of x minus x, our mean, squared. So 82 minus our mean, 71.71, we have 10.28. Squared it, and we have the answer, 105.88. So let's just copy that, square this, and add, and now we have our sum of squares. So same as this one, 71 minus its mean, multiplied it by itself, and we have 1.66. Add this all, and we have the summation of squared in our second group, in our second column, which is 814.22. Same as this one, 64 minus 76.57 squared, we have 158, and add, and then we have our sum of squares of in sub 3, 923.33. Now let's find the K and these values. The number of treatment conditions, 3. So we have year 1 scores, year 2 scores, and year 3 scores. N is the number of scores in each treatment. So we have 7, since 1, 2, 3, 4, 5, 6, 7. That's our N. the big letter N, total number of scores, we have 21. So since we have 3 treatments times the 7 or N, we have 21. 7, 14, 21. Now, in finding the summation of X, the sum of all scores in the study, we just need to add this. I add this 1. So, the summation of this one, the summation of this one, the summation of this one, add this 3, and now we have our summation of X, 1565. Now, in finding the summation of X squared, sum of all squared of scores in the study, we just need to add this. Since we did it earlier, X squared of this, the summation of X squared of this X sub 1, we have 37,040. This one we have 40,427 equals, that's equals to, and this one we have 42,064. So add this 3, we have the total of 119,531. Now, let's go to our ANOVA table one way. So, we have source, the SS, DF, MS, and F. In which our source, we have the between treatments and the within treatments and the total. Now, we find our sum of squares of total using the formula, the summation of X squared minus the summation of X, and squared it and then divide it by N. Since the summation of X squared, we did it earlier, the value is 119,531 minus our summation of X is 1565. Squared it over 21 since our N is 21, right? So 2,449,225 over 21, we now have 116,629.76. So minus these two values and we have the total 2,901.24. Now let's go and find our sum of squares within treatments using the formula SS within summation of SS inside each treatment. So add this 3 sum of squares. So we have 1,039.4 plus 814.22 plus 923.33. Add this 3 and we have the sum of squares of the within treatments now 2,777. Next, we find our sum of squares between treatments using the formula SS between. Is equals to SS total minus the SS within. So we just need to minus this one to obtain our between treatments. So our between treatment, our SS between now is 124.24. So in finding the degrees of freedom, or DF, the DF total is equals to Rn minus the 1. Rn, right, is 21. 21 minus 1 is equals to 20. Now our DF within is equals to N minus K. Rn, right, is 21. So 21 minus Rk is 3. 21 minus 3, we have 18. DF between is equals to K minus 1. Since Rk is 3, right? So 3 minus 1 is 2. So this is now our DFs. Now let's find our mean of sum of squares, or MS. So in finding this in MS between, we just need to divide its sum of squares between, divide of its the DF between. So in this one, 124.24 divided by 2, we have our MS, the 62.12. So divide this 2,777 to its 18, we have now 154.28, and that's now our mean of squares. Now let's find our F ratio statistic, which is MST over MSE as mentioned earlier. So now we have MST is this one, our between treatments 62.12 divided by within treatments, our MSE. So 62.12 divided by 154.28, we now have our F ratio statistics 0.5. 40. Now, next, let's find the tabular value of f, in which, with the help of this table, we have the f denominator equals to within treatments, that is 18, and then our df numerator is equal to treatments 2. This 18 and 2. So let's find it. 2 and 18, and that's now our f critical, or for value of our f in tabular, the 3.55. So let's compare the f ratio statistic or computed value to the f critical value of our table f. So our f ratio is 0.40. Our table f2 into 18, we have 3.55. So in this case, let's compare, and as you can see, our f ratio is less than our table f. So in this case, we can't go with this meaning. So in here, if no real difference exists between the tested groups, which is called the null hypothesis, the result of the ANOVA's f ratio statistic will be close to 1. So this is true to our f ratio here. It is close to 1. So therefore, as our f calculated f is less than our f critical, we fail to reject our null hypothesis. Therefore, there's no significant difference between the student study skills in 3 different year levels. So that's our one-way ANOVA. Next, let's discuss about our two-way ANOVA. So our two-way ANOVA, or a two-way ANOVA test, is a statistical test used to determine the effect of two nominal predictor variables on a continuous outcome variable. A two-way ANOVA test tests the effect of two independent variables on a dependent variable. So we have two independent variables in this one. A two-way ANOVA test analyzes the effect of the independent variables on the expected outcome along with their relationship to the outcome itself. So for examples, teachers compare the marks of the students, both male and female, that they obtain regarding to the noise level they have in their class. The noise is categorized by low, medium, and loud. They want to determine whether the marks are affected by the noise and their gender. So in this case, we are discussing the two-way ANOVA. So we have two factors, which is the noise and the gender. So in our given data here, we have our two factors, noise and gender, in which our noise is categorized in 3 levels: low noise, medium noise, and loud noise, in which our another independent variable, the gender, we have male students and female students. Our hypothesis is still the same. If our null hypothesis is that if there's no real difference exists between the tested groups, and our alternative hypothesis is that if at least one group is different from another. So back to our data, let's find the row total and the column total. So this one, we need to find our row total and our column total. So in finding the column total, we need to add just the column here. So we have 10 plus 12 plus 11 plus 9 plus 12 plus 13 plus 10 plus 13. We have our first column, 9 is equals to 90. In our second column, the medium noise, we have 7 plus 9 plus 8 plus 12 plus 13 plus 15 plus 12 plus 12. We have 88 as our second column. In our loud noise, we have 4 plus 5 plus 6 plus 5 plus 6 plus 6 plus 4 plus 4. And we have our third column is equals to 40. Now we have our column total in our 3 columns. Next, we go to our row total in finding our row total. So in our finding our row total, we just need to add the items in this row, which are this one. So 10 plus 12 plus 11 plus 9 in the row male students only, and plus 7 plus 9 plus 8 plus 12 plus 4 plus 5 plus 6 plus 5, we have 98 as our first row. In our second row, in our female students, we have 12 plus 13 plus 10 plus 13 plus 13 plus 15 plus 12 plus 12 plus 6 plus 6 plus 4 plus 4. We have our row total in our second row, 120. So we also need to find our x squared here, as we need it later. So 10 squared, we have 100, 12 squared, 144, and then add this one, and we have our summation of 1328. Same as this one, 7 squared is equals to 49. Same here, squared, square them all, and then we have these items and sum it up. We have 1020 in our second x squared. And then in our loud noise, we have 4 squared is equals to 16. Then add this all, and we have our summation of x to the sub 3 to the second power, and we have 206. So same as our x squared, we need to square our column total 2 to just because we need it later in our solution, so we can square it earlier. So we have here 90, so square the 90, squared of 90 is 8100. Square root of 88, we have 7744, and square root of 40, we have 1600. Same as the column, we have here the row 98, and squared it, we have 9604. Square this one, 120, and we have 14,400. So in this case, we need to find this one too. So our C is equals to 3 because it is the number of columns, which is the noise category. So we have 3, the low noise, medium noise, and the loud noise. In our R, the number of rows, the student categories, we have 2, the male students and the female students. The student categories, or what we mean is the gender categories. So our N, total number of observations. So we have 24. Thus we have here 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 4, and 4, and 4, 4, 8, 12, 16, 20, and 24. So total, in our data, we have 24 total number of observations. So our A, small a, number of readings in each column. So this one, how many numbers are there in our column? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So number of readings in each row. So we have 1, 2, 3, this one 2, this one, and this one. So in this row, we have 12. So 4, 8, 12. Same as this one, 4, 8, 12. So 12, 12 each, and that totals our total number of observations, the 24. So our N, small n, number of students in a group. So how many numbers are there in the group? There are 4, because 1, 2, 3, 4. So 4 here, 4 here, 4 here, 4, 4, and 4. So next is our sum of our X, sum of all the noises in the study. So sum of all the noises. So let's just add this all, sum of this all, or here 90 plus 88 plus 40, we have 218. Next, let's find our summation of X squared. We have the sum of all squared of noise in the study. So here it is this one. So we add this one, 1228 plus 1020 plus 206, and we have 2554 as our summation of X squared. So in our c squared, summation of c squared, we just need to add this 3. Sum of all squared of column total in the study. Since we squared it earlier, so here is our data. So we just need to add this one. So our first c squared, 8,100, add to our second c squared, 7,744, and our third c squared, 1,600. So we have total of 7,444 as our summation of c squared. Same as our summation of r squared, we just need to add this 1. So 9,604 plus 14,400, and we have our 24,004. Now we have our ANOVA table for our two-way. Same as our one-way, we just need to have the source, our sum of squares, our DF, MS, and F. But in this case, our source are more than 3 because we have our 2 independent variables, which is the noise, the gender, and then next we still need to compute our interaction and our residual. So first, we need to find our correction term. Our correction term is Cx is equals to our summation of x squared over n. So our summation of x is 218 here. So square that one, we have 47,524 divided by our n, diba? Our number of observations is 24. So divided by 24, we have our Cx 1980 because we'll be needing this later in our equations. So like this one, in finding our sum of squares of total using the formula, S as total is equals to summation of x squared minus Cx. So we have summation of x squared 2,554, this one, to our Cx, the 1980. So minus this one, and we have 274 as our sum of squares total. So next, we have for variation in noise, we need to find the sum of squares of column using the formula SS column is equals to summation of c squared over a minus cx. So we need to find this one. We already found it, which is 17,444 minus I divided by our a, which is 8 because we have 8 in our column. We're finding our column here, our column total. Because our column total is about our noise, the variation of noise. So that's why we have this formula. 17,444 divided by 8 minus 1,980. So we have 2,181 minus 1,980, and our column is now 201. Our SS column is 201. So same as for finding our variation in gender, which is our row, we need to find the sum of squares of row. That's row. SS row is equals to summation of r squared over b. So our r squared is 24,004 divided by 12 minus 1,980. So 2,000 minus 1,980, we have our SS row as 20. So in our gender, we have 20 sum of squares. So finding our sum of squares within the groups, or we call interaction, we have SS group is equals to summation of x squared group over n minus cx minus SS column minus SS row. So in finding our summation of squared groups, we just need to add all the items in a group and then square it. So in this one, we just need to add this one. So 10 plus 12 plus 11 plus 9, and then squared it. Same as this one, add and squared it, add, squared it, add, then squared it, add all and squared, add all and squared, and then the squared of these items we need to sum it up. And that's our summation of x squared over summation of our x squared groups over n. So we have 8,868 in doing this equation. Over n, we have 2,217. So our cx right is 1,980. So our ss column, we have 201. As our ss row, we have 20. So minus them all, we have 16 as our ss group or within groups. Next, we find our residual sum of squares of error using the formula ss error is equals to ss total minus ss column minus ss row minus the ss group. So ss error is equals to 274, our total, minus 201, minus 20, minus 16, and we have our ss error is equals to 37. Now that we have our sum of squares, we go to our degrees of freedom in finding our degrees of freedom. So same as our one-way ANOVA table, and in our finding our df, we have these formulas. So in this case, in a total, we have n minus 1 is equals to, we have total of 24, right? 24 minus 1 is equals to 23. df noise, we have the column. How many columns are there? 3 minus 1 is equals to 2. So 2 is our df in our noise. And our gender, it is our row, right? So we have 2 categories of our gender, the male and the female. 2 minus 1 is equals to 1. So we have df to the gender 1. df interaction, we have c minus 1 multiply by r minus 1. So since our c minus 1 is 2, r minus 1 is 1. So 2 times 1 is equals to 2. So we have our interaction, df interaction equals to 2. Next, we find our df residual, that is equals to cr, our c times our row, multiplied by n minus 1 is equals to, we have c as 3, our r is 2, our n is 4, 4 minus 1, so we have 3 times 2, 6, 4 minus 1, 3, so 6 times 3, we have 18. So our df in our residual or our error is 18. Next, we need to find our mean of sum of squares. In finding the mean of sum of squares in noise, we just need to follow this formula. So ms noise over its sum of squares over the degree of freedom. So we have 201 divided by 2, we have 101. In our gender, same, 20 divided by 1, we have 20. And in our interaction, we have 16 over 2, and we have 8. In our ms residual, same, 37, its ss, over its df, we have 2.06. Now we can compute our f ratio statistic. It is the mean of sum of treatments over which the mean sum of treatments over mean of sum of errors or the residual. So this is our residual or our sum of errors. So this is our denominator. So as you notice, it has the same denominator, that 2.06. So our MST treatments, 101 divided by 2.06 as our to find our f ratio in noise. So 101 divided by 2.06, we have 49.03 as our f ratio in noise. And in gender, we have MST over MSE, 20 divided by 2.06, 20 divided by 2.06, we have 9.71. In our interaction, same, 8 divided by 2.06, and we have 3.88. Now that we find our F ratio, let's find our tabular value of F. So we have here our table F. So let's find the F denominator, which is the residual. So this is our denominator, our 18. And our numerator, since we have 3 that we're comparing, so we have noise, that is equals to 2, gender, 1, interaction, 2. So in this case, we have 3 table of F that we'll find since we have 3 F ratios 2. So 18 and 2. 2, 18, we have 3.55. This one, 1, and then 18, we have 4.41. And this one, still same with the noise. 2 and 18, 3.55. So now that we find our F critical value or table F, let's compare the F ratio to our critical value. So our F noise is equals to 49.03, and our table F into 18, we have 3.55. Our gender, we have 9.71, and our table F, we have 4.41. F interaction, we have 3.88 as our F ratio. In our table F, we have 3.55. So as you notice, in this case, this one is greater than our table F. This one is greater than our table F. This one is also greater than our table F. So if our F ratio statistic is greater than the table F, we reject our null hypothesis. So as our F cal in here is greater than our F critical, we reject our null hypothesis. So therefore, noise does have a significant effect on marks obtained. Next, we have our gender. As F cal is greater than F critical, we reject our null hypothesis. So therefore, the gender does have a significant effect on marks obtained. Same as in our interaction, since our F ratio is greater than our table F cal is greater than our F crit, we reject our null hypothesis. Therefore, different genders behave differently to the noise. Another example. Consider the following data from the experiment that compares the weights of poplar trees grown in 2 different locations. At each location, the methods used to grow the trees were as follows: the control, the fertilizer, and the irrigation. Conduct a test to determine whether the weight of trees is affected by location and treatment. So we still use our two-way ANOVA here because we have 2 independent variables, or 2 factors, which are the treatment and the location. So in treatment, we have 3 categories: the fertilizer, and the irrigation. In our location, we have 2: the site 1, which is rich and moist, and the site 2, which is the sandy and dry. So this is our data. Next, we find our hypothesis. So same as the first example, our null hypothesis is if there's no interaction between the site and treatment. And our alternative hypothesis is that there's an interaction between the site and the treatment that exists. So back to our data, let's find the row total and the column total. So same as we did earlier, let's just add this all, and we have our column total. Add this, and we have our column total. Add this all, and we have our column total. And in here, we have to add this one, and add this one as our row total, which is 3.4. And then we add here and add this one and third column, and then we have our row total 6.76. Now that we have our row and column, let's try to no rx squared because we'll be using it earlier, as I've said many times. 0.15 squared that one, and we have 0.02. Square this one, square this one, square them all and add them all, and we have our summation of x sub 1 to our second power. Now we have 2.03. Same as this one, x squared of 1.34 equals to 1.80, and add this all, we have 5.33. X squared of 0.23, in this column, we have 0.05, add them all, and we have 1.02. Now that we have that, let's look here as we need it later in our equations. So, same as our first example, there are 3. C, our C is number of columns or our treatment categories. So, the none, the fertilizer, and the irrigation. So, there are 3. RR, number of rows or location categories. We have 2. So, we have 2 locations, right? The site 1 and the site 2. So, 30 is our N or our total number of weights. So, we just need to add this all, the numbers, not numbers, but how many are there in the column. So, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, multiplied by 3 because there are 3 treatments. We have 30 as our N. So, as I mentioned earlier, we have 10 in a number of readings in each column. We have 10 here, we have 10 here, we have 10 here, and that is our A. While our B is the number of readings in each row. We have 15 since we have 5 here, 5 here, and 5 here. So 5 plus 5 plus 5, we have 15. So now we have 5 as our N as number of weights in a group. So, as I mentioned earlier, we have 5 here, 5 here, 5 here, 5, 5, and 5. So, our N is 5. So, our summation of X, sum of all the weights in the study. So, we just need to add this one, and add this one. So, that's example here. So, we have 3.21 plus 4.81 plus 2.21. And we have our summation of X equals to 10.23. Next, we have our summation of X squared. This one. Since we did it earlier, we have our X squared 2.03 plus 5.33 plus 1.02, and we have 8.38 as our summation of X squared. Next, the summation of our C squared, or the sum of all squared of the column total in the study. So, we need to square this one, and square this one. So, squared of this 3.21, we have 10.30. Add this in our second column, 23.15 plus 4.88, and we have 38.32 as our summation of C squared. So, our summation of R squared, same as we did in our column, we just need to add this one because this is the square of our R. So 3.4 squared this one, we have 11.56, 6.76, and square this one, we have 45.70. Add this one, and we have the total of 57.26 as our summation of R squared. Now we have our ANOVA table in two-way. So, first we need to find our correction term, right? So, we have summation of x and squared it over n. Our n is 30. Our summation of x is 10.23 here over 30. So, that one, squared that one, 104.65 over 30, and we have 3.49 as our correction term. Next, we find our sum of squares of total using the formula SS total is equals to summation of x squared minus cx. SS total is equals to 8.38 minus 3.49. And we have our SS total is equals to 4.89. For variation in treatment, for a column, we need to find sum of squares of column using the formula SS column is equal to summation of C squared over A minus CX. So our A, diba? Right is 10. So C squared natin is 38.32. 38.32 divided by 10, we have 3.83 and minus it with our CX, that is 3.49. We have now our SS column 0.34. The same as in finding our variation and location, we need to find the sum of squares of row using the formula SS row is equals to summation of R squared over B minus CX. So our SS row is equals to 57.26 divided by our B, which is 15 because we have 15 in our row, right? So minus 3.49. This one divide this one, we have 3.82 minus 3.49. We have SS row as our 0. We have now 0.33 as our sum of squares of row. Now we need to find the sum of squares within groups using the formula x squared, summation of x squared over g over n. So as I did earlier, so this one, we need to add them and then squared, and we have an answer for the first group. So let me show you here. So we just need to add this and square them. Now you have the answer earlier. As you see, this is the one. We also need to do that in this one, this one, this one, this one, this one. So add the square of the items, the total, and you will have our summation of x group. So summation of x squared group is divided by n. So 21, we have 21.37 over 5. 5 is our n because we have 5 total of 5 in our group. So our CX is 3.49. Our SS column is 0.34. Our SS row is 0.33. So minus them all, and we have our SSG or SS group within groups equals to 0.11. Next, we find the residual sum of squares of error using the formula SS error SS is equals to SS total minus SS column, SS row, and SS group. So we have our total 4.89 minus our column 0.34 minus our location or our row and our interaction or our group 0.11. Now we have our SS error or the residual 4.11 as our answer. Next, we find our degrees of freedom. Same formulas as we did earlier. So we have TF total is equals to n minus 1 is equals to, there are 30, right? Because 5 plus 5 plus 5 plus 5 and 5. We have 30 minus 1 equals to 29. So our total of DF is 29. Our treatment is C minus 1. We have 3 columns, right? The normal, the medium, and the loud. So 3 minus 1 is equals to 2. We have now 2 as our DF in treatment. DF location, we have equals to R minus 1. We have 2 rows. The site 1 and the site 2. 2 minus 1 is equals to 1. So DF interaction, we have this formula. C minus 1 multiplied by R minus 1. So 2 times 1, we have 2 as our DF in our interaction. In our residual, we have this formula, CR, C times R, times n minus 1. So our n is 5, right? So 3 times 2 is 6. Our n is 5, so 5 minus 1 is 4. So 6 times 4 is 24. And we have our degrees of freedom in residual. Next, we have to find our mean of squares or MS, which the formula is MS treatment over its sum of squares over its degree of freedom. So 0.34 divided by 2, we have 0.17. 0.33 divided by 1, we have 0.33. 0.11 divided by 2, we have 0.06. 4.11 divided by 24, and we have 0.17. Now we find our F ratio statistic. Mean of sum of treatments over mean of sum of errors or the residual. So MST over MSE. So our MSE is the residual. So we have 0.17. So this is our denominator. So in our treatment, we have 0.17 divided by 0.17, we have 1. In our MS location, we have 0.33 divided by 0.17, and we have 1.94. 0.06 divided by our 0.17, and we have our F ratio 0.35 in our interaction. Next, we find the tabular value of our F. Now that we find our F ratio, let's find our tabular value of F. First, we need to determine our DF denominator, which is the residual. Of course, it is 24. And our numerator is the treatment, location, interaction, the DF of these three. The 2, treatment is equals to 2, location is equals to 1, and interaction is equals to 2. So 2 treatment 2 to 24, we have 3.40, and location 1 and 24, we have 4.26. Interaction 2, we have 2, and 2 and 24, we have 3.42. Then compare the F ratio or the computed value to the F critical value of table of F. So same earlier, we need to compare them. So as I mentioned earlier, 1 at 224 is 3.40. So this is our table F into 24. Same here. In our table in F1 24, we have 4.26. So our treatment here, location, interaction. So comparing these three, as you've noticed, 1 is lesser than our table F. Here is 1.94 lesser than our 4.26. This one, 0.35 is lesser than our 3.40. So, since F ratio, if our F ratio statistics is greater than the table F, we reject HO. But in this case, we have our F ratio lesser than our table F. In this case, we fail to reject our null hypothesis because our FCAL is lesser than critical. So therefore, treatment does not have a significant effect on the weights of the trees. Same as our location does not have a significant effect on the weights of our trees. And therefore, there's no interaction between the site and the treatment. So that's all for our two-way ANOVA that have two independent variables, and the one-way only have one. Lastly, we have our three-way ANOVA. The three-way ANOVA is used by statisticians to determine whether there is a three-way relationship among variables on an outcome. It determines what effect, if any, three factors have had an outcome. Three-way ANOVAs are useful for gaining an understanding of complex interactions where more than one variable may influence the result and have many applications in finance, social science, and medical research, among a host of other fields. For example, determine the effects of educational attainment, socioeconomic status, and employment status on the number of children delivered alive by the female respondents. So, in our three-way ANOVA, we now have three factors. In this case, in our example, we have educational attainment, the socioeconomic status, and the employment status. So, our educational attainment have two categories, which is the college graduate and the college undergraduate. Our socioeconomic status have three categories: the high, the average, and the low, while our employment status have two categories, which are the employed and the unemployed, under the first column of our educational attainment, and this one also employed and unemployed under the college undergraduate, and that is our data. So let's find our hypothesis. Null hypothesis is that if there's no real difference exists between the tested groups. Alternative hypothesis is at least one group is different from another. So back to our data. In our example, we have here, let's find first these values. So in finding our value A, the number of columns for educational attainment category. So as said earlier, we have 2. Our B is the number of rows of socioeconomic status category, which is 3. 1, 2, 3. High, average, and low. And we have our C, number of columns for employment status category, and we have 2, the employed and the unemployed. Our N, the total number of the female respondents. So in here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 18, 27, and 36. So in total, we have 36 female respondents. So our small n, the number of female respondents in a group, this one, 1, 2, 3. So we have 3 respondents, female respondents in our group. Next, we make a table. Different table in each different interactions. First is our table of A and B. So in this table, we only have our A and our B. So coming from here, college graduate, college undergraduate, and high, average, and low. So in order to find the values in here, we need to find the college graduate under the high socioeconomic status. So college graduate, we have 5 plus 1 plus 2 plus 4 plus 6 plus 0, and we have 18. This one, same, 8 plus 4 plus 2 plus 1 plus 3 plus 0. This one, in college graduate, under the average, we have 18 too. In low, we have 5 plus 3 plus 8 plus 8 plus 6 plus 2, and we have 32. So same as in finding our college undergraduate column, we have 3 plus 2 plus 6 plus 7 plus 4 plus 3, we have 25, 4 plus 7 plus 0 plus 1 plus 6 plus 1, we have 19. In college undergraduate here, 5 plus 1 plus 7 plus 4 plus 5 plus 3, and we have 25. So this one, we also need to find our row total and our column total. So 18 plus 25, and we have 43. 18 plus 19, 37. 32 plus 25 is equals to 57, and in our column, we have 18 plus 18 plus 32, we have 68. 25 plus 19 plus 25, we have 69. Next, we go to our table B times C, or BC. B by C, I mean. So in this one, we have the B and our C. So in our original table, let's find our B and C here. So high, 5 plus 1 plus 2, since it is employed. And this one, 2 is employed, so we need to add this one and this one. So 5 plus 1 plus 2 plus 3 plus 2 plus 6, we have 19. So same as in finding our average under the employed category, we have 8 plus 4 plus 2 plus 4 plus 7 plus 0, we have 25. In low, we have 5 plus 3 plus 8 plus 5 plus 1 plus 7, we have 29. So in unemployed, we have 0.6 plus 4 plus 4 plus 7 plus 4 plus 3, and we have 24. 0 plus 3 plus 1 plus 1 plus 6 plus 1, we have 12. And in low, we have 28, since we have 8 plus 6 plus 2 plus 4 plus 5 plus 3. So Let's find the row total and the column total. So add this one, we have 43. Add 37. Add 57. Add this one, 19 plus 25 plus 29, we have 73. 24 plus 12 plus 28, and we have 64. And that's our table B times B by C. Next, we find our table by C, which is a college graduate and a college undergraduate, the educational attainment, and our employment status, are employed and unemployed. So in order to find this value, college undergraduate, the unemployed, add this all. 5 plus 1 plus 2 plus 8 plus 4 plus 2 plus 5 plus 3 plus 8, and we have 38. While in unemployed, we add this, the unemployed column, under the college graduate. So we have 0 plus 6 plus 4 plus 0 plus 3 plus 1 plus 8 plus 6 plus 2, and we have 30. So same as in under the college undergraduate, employed, this column, 3 plus 2 plus 6 plus 4 plus 7 plus 0 plus 5 plus 1 plus 7, and we have 35. This one, in unemployed, 7 plus 4 plus 3 plus 1 plus 6 plus 1 plus 4 plus 5 plus 3, and we have 34. So we also need to find our row total and our column total. So 38 plus 35, we have 73. 30 plus 44, we have 64. In column, 38 plus 30, we have 68. 35 plus 34, we have 69. And that's our table A by C. Next, we'll find our table A by B by C, which is a college graduate in college undergraduate. This is our educational attainment. This is our socioeconomic status. And our C is the employment status. So in order to find these values, we need to add this one. 5 plus 1 plus 2 is equals to 8. 0 plus 6 plus 4, we have 10. The employed in undergraduate and high, 3 plus 2 plus 6, we have 11. So on. 7 plus 4 plus 3, 14. 8 plus 4 plus 2, we have 14. 0 plus 3 plus 1, we have 4. 4 plus 7 equals to 11. 1 plus 6 plus 1, we have 8. 5 plus 3 plus 8, we have 16. 8 plus 6 plus 2, we have 16. 5 plus 1 plus 7 and 13. 4, 5, and 3, we have 12. And we need to also know the row total and the column total. So 8 plus 10 plus 11 plus 14, we have 43. 14 plus 4 plus 11 plus 8, we have 37. 16 plus 16 plus 13 plus 12, we have 57. So in this one, in our column, we still need to add this one. 8 plus 14 plus 16, we have 38. 10 plus 4 plus 16, we have 30. 11 plus 11 plus 13, we have 35. And 14 plus 8 plus 12, we have 34. So that's our table A by B by C. Next, let's go back to our table A by B, which is the educational attainment and our social economic status. In this case, in this table, we now going to find our A squared, and our C, A sub 1 squared, and our row total, row B sub 1 squared. So how to find this one? So let's find first our A squared. So we just need to square this one. 18 squared is equals to 324. 18 to the second power, 324. 32 squared is equals to 1024. So same as this one. 25 squared, we have 625. 19 squared, we have 361. 25 squared, we have 625. So in finding our summation of A squared, we just need to add this one. And we have this. Answer 1672 plus the summation of our sub 2. Summation of our A sub 2, which is the 1611. So 1672 plus 1611, we now have our summation of A squared, the sum of squared of number of female respondents under the educational attainments in the study. Next, let's find our summation of C A squared, the sum of all squared of column total of educational attainment in the study. So in a column of this one. So the total of column here is 68. So we just need to square this one and this one too. So square of 68, the 68 squared is equals to 4,624, and the 69 to the second power we have 4,761. We just need to add this to 4,624 plus 4,761, and we have our summation of C the sub A squared, and we have a total of 9,385. We'll be needing these numbers later in our solutions. Next, we have our row. So same as our column, we just need to square this one. 43 squared is equal to 1,849. 37 squared, we have 1,369. And our 57 squared, we have 3,249. So add this all, and we have a total of 6,467 as our summation of our B squared. After that, we go to our table B by C. So our B, socioeconomic, and our employment status. So same as we did in our table A and B, we need to find its squared and the squared of this column. So 19 squared, we have 361. 24 squared, we have 576. So just need to add, and we have this total. Add, and we have this total, and this, and add this summation of B. Add this to 1,827 plus 1,504. We have the summation of B squared as 3,331. So our column is 19 plus 25 plus 29, we have 73. So let's just square this value. 73 squared, we have 5,329. So 64 squared, we have 4,096. 5,329 plus 4,096, and we have the answer 9,425 in our summation of C sub C squared. Now let's go to our table A by C, which is our A, educational attainment, and our C, the employment status. So let's find our summation of C squared, sum of all squared number of female respondents under employment status in the study. So let's just square this one, 38, and square it, we have 144. 30 squared, we have 900. We just add this one, and we have the total of 2,344. And same as this, 35 squared, we have 1,225. 34 squared, we have 1,156. Add, and we have 2,381. Add the two summations of C squared, and we have 4,725 as our summation of C squared. Next, let's go to our table A by B by C. So this is a complete table. So here, in this case, we need to find our summation of A in our sub C squared, sum of all the number of female respondents in the group of study, So 8 squared, we have 64. 14 squared, we have 196. 16 squared, we have 256. Let's just add this all, and we have the summation of A in the sub 1 of the column 1. We have 516. So same as here, square these items here, and we have 372. Square this one and add, we have 411. Square this one and add, we have 404. So let's add these four values, 516, 372 plus 411 plus 404, and now we have our answer, 1,703 as our summation of A and our column squared. Next, let's go and find our correction term. So Cx, our formula is our Cx is equals to summation of x squared over n. So our summation of x is the total of these values. So 38 plus 30 plus 35 plus 34, we have 137. So square that one, we have 18,769 divided by 36, since we have 36 as our n. As you see here, we have 36 as total number of our female respondents. Okay, so let's divide this. 18,769 divided by 36, we have 521.36 as our Cx or correction term. So, for variation in educational attainment, we need to find the sum of squares of column in table A by B. This is our table A by B. Using the formula SSA, A is our educational attainment, right? So SSA is equals to summation of C A squared over NBC minus CX. So our summation of C A squared, this one and this one, let's just add this one, and we have 9,385 over 3 times 3 times 2. So our n is 3. Since we have 3 n, we have the 3n. And then our b is also 3. We have the average, and the low. While our c is the employment status. Remember that the unemployed and the employed. So we have 2. So that's why 3 times 3 times 2. 3 times 3 times 2 is 18. So we need to divide this one, and we have 521.39 minus our CX 521.36, and we have our SSA as 0.03. Next, same as in our finding variation of our socioeconomic status, the sum of squares of this one, we also need to use the table A by B to find the summation of RB squared. So this is the summation of RB squared. Just add this one and you'll find the summation of RB squared. So the summation of RB squared is 6,467. In this case, our denominator is n times A times C. So our n is 3, right? So our A is 2, 1, and 2. And our C is, as I've said, the employment and the unemployed. So we have 2. So 3 times 2 times 2 is 12. So 6,467 divided by 12, we have 538.92. And minus it, we have 521.36. And minus it with the 521.36, we have the answer 17.56 as our SSB, or sum of squares in our B, socioeconomic status. Next, we have our for variation in employment status, or our C, we need to find the sum of squares of column in table B by C. Using the formula, SSC is equals to summation of C squared over NAB minus CX. So using the table B by C, we find our numbers here. So add this one and add this one, we have 9,425 over our N is 3, our A is 2, our B is 3, this one 3, and our 2 is the educational attainment, the graduate and the undergraduates. So we have 3 times 2 times 3, we have 18. So 9,425 divided by 18, we have 523.61 minus 521.36. And we have the answer for our SSC equals to 2.25. Next, find the sum of squares within group of educational attainment and socio-economic status in table AB using the formula SSAB is equals to summation of a squared in AB minus a over NC minus summation of CA squared over NBC minus summation of RB squared minus over NAC plus CX. So our summation of A squared, A by C, this is our A by B. So we have this one plus this one, the summation of A squared. Let's add this, and we have 3,283. So our NC over NC, our N is 3, right? And our C is 2. The unemployed and the employed. So this one, we already calculated it. So we just need to put it like this one, CA squared. We have this CA squared, right? So 521.39. And our, so that one, so our summation of RB squared over NAC, we have this 538.82. Because we already solved it earlier, so we can put it there already. So that's our values. So 3,283 divided by 3 times 2, 6 divided by 6, we have 547.17. So minus them all plus the value of CX, we have our summation of our A by B equals to 8.22. Now, in finding the squares within group of socioeconomic status and the employment status in table B by C, we use the formula, the summation of B squared B by C over NA minus RB squared over NAC minus summation of C squared over NAB plus CX. So this one and this one, we already have the values, we just put here. So in this case, in finding this value, we just need to add the B squared, summation of the B squared. So we have 3,331 over 3, N is 3, our A is 2, the educational attainment, the college and the undergraduate. So 3 times 2 is 6. So we divide this by 6. And we have 555.17 and minus this 2 plus the CX. And we have our summation of B by C equals to 14. Next, let's go to our table by A by C to find the sum of squares within group of educational attainment and employment status. We use the formula SSA by C equals to C summation of C squared A by C over NB minus summation of CA squared over NBC minus summation of CC squared over NAB plus CX. So this one again, we already have the values of that, so we can put it here. So summation of C squared over A by C, we just need to add this summation of C squared of the two columns. So we have now 4,725 over N is 3, our B is 3, the socioeconomic status. So we have 3 times 3 equals to 9. 4,725 divided by 9, we have 525. 525 and minus this with the two values plus the CX, and we have our SS in our A by C equals to 1.36. Now let's find our sum of squares of total using the formula SS total is equals to summation of x squared minus CX. So finding our summation of x squared, we can use our table A by B by C. Here, we just need to square this one, this, squared it. We have this, and total 212 in our summation of x sub 1. This one squared, and then add, we have summation of x. In our summation of x sub 2, we have 166. Summation of our x sub 3 squared, we have 189. And this one, in our summation of x sub 4 squared, we have 162. We just need to add this 4, and we have the total of 729. 729 minus 521.36, and we have our SS total as 207.64. So now we can put our ANOVA table in our three-way ANOVA, which is we have also the source, the SS, the DF, the MS, and the F, in which in this case we have many sources. We have the A, the B, the C, the A by B, B by C, A by C, A by B by C, the residual, and the total. In this case, we already have our SS. We computed it earlier, so we just put it here, in which A is 0.03, our B is 17.56, the sum of squares of our C is 2.25, the A by B is 8.22, and so on. So in finding the residual sum of squares of error using the formula, SS error is equals to SS total minus our SSA minus our SSB minus our SSC minus our SSA by B minus our SSA by B by C, minus SSB by C minus SSA by C, and minus SSA by B by C. So let's just minus this one to minus this all here to our total in order to find this residual. So our residual now, or error, is sum of squares of our error is 161.3. Now let's find our degrees of freedom. So let's have it has also just the same formula. In df total, the n minus 1, we have 36, right? Our n is 36, minus 1 is equals to 35. Now we have 35 as our df. dfa, we have a minus 1. So our a, we have 2. The educational attainment, the graduate and the undergraduate. So we have 2, right? So minus 1 is equals to 1. That's now our df. Our dfb is equals to b minus 1 is equals to, we have 3b, the socioeconomic status, minus 1, we have 2. Our dfc, we have c minus 1, which is equals to 2 minus 1 because we have 2, the employed and the unemployed. Now it is equals to 1, so we put it here, there. So in finding our degrees of freedom in A by B, we just need to multiply the df of our A and our df of our B. So we have 1 times 2 is equals to 2. In our dfb by C, we just need to multiply the df of B and the df of C, which is 2 times 1 equals to 2. And our df of A by C, we have A minus 1 and C minus 1 because this is the formula for their df's. So let's just multiply it. 1 times 1 is equals to 1. And the df A by B by C, so same as this 3. We just need to multiply the df of A, the df of B, and the df of C. So we have 1 times 2 times 1, we have 2. In our residual, we just multiply the value of our A, of our B, and our C, multiplied by our n minus 1. Our n is 3. So 3 minus 1, we have 2. So 2, our A is 2, our B is 3, our C is 2. So we have 12 times 2 equals to 24. So now we have our df's. Next, let's go and find our mean of sum of squares. So our mean of sum of squares in our A is SSA over dfa. So we just need to divide this one to our df. So divide 0.03 divided by 1, 0.03. 17.56 divided by 2, we have 8.78, and so on. Divide here, divide this one, divide. So this is the formula. And that's how we find our mean of sum of squares. Next, in finding our F ratio statistics, or the mean of sum of treatments over mean of sum of errors, or the residual, our residual there is 6.72. So our denominator is 6.72. So our numerator now is the RMS in each row. So our MS 0.03 divided by 6.72, we have 0.0045 as our F ratio. So let's just make it, solve it in our groups there. Just need to divide this by 6.72, divide this one, divide this one, divide, and divide, and then this is our quotients. And now that's how you find our F ratio. Now that we find our F ratio, next we find the tabular value of our F with the help of our table F here. So our DF denominator is our residual, right? Which is 24. So our denominator is 24. Our DF numerator is this DFs. So our A, 1, our B is 2, our C is 1, A by B 2, B by C is equals to 2, our A by C is equals to 1, and A by B by C we have 2. So I'm finding it here, and let's put in this one. So we have F in 124. 124 we have 4.26. That's our for FA. In FB we have F224. So 2 and 24 we have 3.40. Since some are having the same values of table F, we'll just copy it because it has the same value there. So that's our value of our F critical. So now let's compare our F ratio statistic to our F critical value. So let's put our value of F here, there. Okay. Now, as you notice, our F's, FA or FB, our FC, our FA by B, FB by C, and FA by C, and F by B by C is lesser than our table F's. Look, smaller, it is lesser, less than, it's lesser, it is lesser than our table F. So, if no real difference exists within the tested groups, which is called the null hypothesis, the result of the ANOVA's F ratio statistic will be close to 1. So as you notice, our F's are close to 1. So in this case, as all our F-cal, these are calculated F's, less than its F criticals, they're all, we fail to reject null hypothesis. So all of these we fail to reject its null hypothesis. So therefore, there are no significant effects of educational attainment, or A, to our socioeconomic status, to our B, and employment status, to our C, on the number of children delivered alive by the female respondents. So we have no significant effects between A to the B and C, or A to the C, B to the C, and C to the A by B by C. There are no effects. So that's our three-way ANOVA. Another example. You are interested in the effect of two different types of exercise program for improving marathon running performance. However, you are concerned that the effect that each type of exercise program has on marathon running performance might be different for males and females, as well as if you are normal weight or obese. Indeed, you suspect that the effect of the type of the exercise program on marathon running performance will depend on both both your gender and body composition. As such, you want to determine if a three-way interaction effect exists between type of exercise program, gender, and body composition in explaining marathon running performance. So we used our three-way ANOVA here because we have three factors, which are the exercise program, the gender, and the body composition. So this is our table, our data. So this is now our gender, which has also two categories, the male and the female. Our B, the exercise program, the endurance, strength, and balance, categorized as these three. While our body composition, or our C, we have normal and obese under the male and normal obese under the female. So this is our data. Let's find our hypothesis. The null hypothesis of this study is that there's no real difference exists between the tested groups. Alternative hypothesis is that at least one group is different from another. So in our data, this one, let's find first these values. So 2, our A is 2, the number of columns for gender category. We have male and the female, so we have 2. And in finding B, number of rows for exercise program category, we have 3, the endurance, strength, and balance. C, number of columns for body composition category, we have 2, the normal and obese. And total number of the respondents, we have 36. We just need to add this all. We have 36 respondents. 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, and 7, and 36. So n, small n, number of the time run for marathon in a group. So how many are there in a group? 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's our small n. Now, let's find our A by B. Our A is this one, male and female, or gender, and our B is our exercise program. So as I mentioned earlier, just to find this one, just need to add all of here. We have 27. Add this one. We have 24.5. Add this one. And we have 20.5. And then we have our column total 72. So this goes in here. 78. This one too, we have 48.5. Our row total 24.5 plus 27.5. We have row total 52. And we have the row total of our balance 20.5 plus 29 equals to 49.5. In our table B by C, so we have our B exercise program and C are the normal and the obese. So we have to find this value. In order to find that value, we just need to add this one, this thing, this 3 and 3. Normal in under the endurance. So we have 10.5. And then this one, add this one, add this one, this one. The answer 4.50 plus 1 plus this 3 under the balance. We have this one, and so on. Same with the obese. Add that one and that one. We have this. Add this one, this 3, and this 3. We have 38. Add this 4.456 and 4.998, and we have this 36. So add this to have the column total, the 38 and the 112. So in row total, we have 48.5, 52, and 49.5. Next, our A by C. So this is our A, the gender, male and female, and our C, the body composition, normal and obese. So in order to find this value, just need to add this one, this column, all this column, in normal male. In obese male, we have this 55. female and normal, female, normal, add this column, and we have 21. Female and obese, we have this one, this column, and we have this value. So let's just add this thing. 17 plus 55, we have 72. 21 plus 57, we have 78. This one, add, and that's our row total. In table A by B by C, we have all the A and the B and the C. We have the gender, we have the body composition, and the exercise program. So in order to find this value, we just need to add each group. So that's the in each group. That one, each group. So let's add this, and we have 17. Add this, we have 55. Add this, and we have 21. Add this, and we have 57. And then in row, just add this, and 48.5. Add this, and then we have 52. Add this, and we have 49.5. Now let's find our summation of A squared, sum of all squared of number of time run under gender in the study. So in finding this one, we just need to square our values in our under the gender and our endurance. So we have A squared. So 27 squared is equals to 729. Square this one, we have this answer. Square this one, we have this answer. And then add this all to obtain the summation of A into sub 1 squared, 1750. So same as this one, square this one, we have this, squared, we have this answer, squared, we have this answer. And now we have our summation of A sub 2 squared equals to 2060. So 1750 plus 2060, we have our summation of A squared, 3810. So in finding our summation of CA squared, we sum all squared of column total of gender in the study. So we just need to add this, and then this is the column total, square this one, so to obtain this value. So square this, and this is the value. So 5184 plus 6084, we just need to add these two to obtain our summation of CA squared, 11,268. In finding our summation of RB squared, as I said earlier, we just need to square this one, and this is our value, squared, this is our value, squared, and this is our value. Add these three row totals, squared, and we will have our answer, 7,507. Next, let's find our summation of B squared. So just same as finding the summation of A squared, we just need to square this one using our table B by C. So 10.5 squared, squared this one, and answer, squared, this is the answer. Add this, and we have summation of B sub 1 squared, 489, and this one squared, and add, and summation, and now we have the summation of B sub 2 squared, 4184. Add these two, and we have the answer, 4673. Now, in finding the summation of C squared, sum of all squared of column total of body composition in the study, we have this one. Just need to square this as we did earlier. So 38 squared, we have this answer. 112 squared, we have this answer. So now we have 13,988. In table A by C, we can find our summation of C squared, sum of all squared of number of time run under body composition in the study. So we just need to square this, and then add. We have now summation of C sub 1 squared, 3,314, plus our summation of C squared, C sub 2 squared, 3,690, and we have 7,004 as our answer. Next, let's find our summation of AC squared, the sum of all the number of time run in groups in the study. So this is in groups. So in the use of table A by C, we will find this one. This is complete. That's a 5. It is by groups. So 5 multiplied by itself, we have 25. So let's just add this, and we have this value 98. So in our second column, we have 1033. Third column, we have 151, and we have 1097 in the last column. So let's just add this 4, and we have 2379 as our value. Next, finding our correction term. Cx is equals to summation of x squared over n. So we have 150 since we need to add this one, this one, this one. So the total of that is 150. And squared it, we have 22,500 over 36. It is the use of A by C, the table we made earlier. So 36, we have 36 as our n because it is a total of the number of the respondents. So divide that, and we have our Cx equals to 625. Now for variation in gender, we need to find the sum of squares of column in table A by B using the formulas SSA summation of CA squared. So we already encountered this equation, so we just need to add this one. Add this one and this one to obtain the value 11,268 over our n is 3, our b is 3, this one 1, 2, 3, and our c is 2, the weight, the normal, and the obese. So we have 3 times 3 times 2, we have 18. So 11,268 divided by 18, we have 626, and our cx is 625, right? So we just minus that one, and our SSA now is 1. Now for variation exercise program, or our B, we need to find the sum of squares of row in table A by B using the formula. With the help of this table A by B, so just need to find this one, which is here. Just need to square this. We already squared that, and add this 3, and we have 7,507 over NAC. N is 3, right? And our A is 2, the male and female. Our C is 2, as I've said earlier, the weight, the body composition, I mean. So our SSB now is equals to 7,507 over 12 equals to minus 625 equals to 625.58 minus 625, we have 0.58 as our SSB. For variation in body composition, we need to find the sum of squares of column in table B by C using the formula, this one. So this one, we need to use the B by C. Let's find the summation of CC squared over NAB. So CC summation of C in the C squared, we have this one, CC squared, and in the sub 2, so let's just add these 2, and we have 13,988 over N is 3, A is B, or B is 3. This 1, 2, 3. So now 13,988 divided by 18, we have 777.11 minus 625, and our SSC now is 152.11. Now let's find the sum of summations within group of gender exercise program in table A by B using the formula, this one. So this one within group. Let's find the SS of A by B. So summation, the formula is this. Summation of A squared in A by B over NC minus summation of C A squared over NBC minus summation of RB squared over NAC plus CX. So in summation of A squared in our A by B, just need to add this one, the summation of the A squared of these values. So this one, summation, and then add these two, and that's the value of here. So we have 3,810. So our N is 3, our C is 2. So we have 6. So the values of this, as I've said earlier, are we already computed it, so we can put it here, the values. So now we have 3,810 divided by 6, we have 635. So 635 minus 626 minus 625.58 plus 625 as our CX. We now have summation of squares in our AB equals to 8.42. Now, in finding the sum of squares within the group of exercise program and the body composition, or the B by C, we need to find it in our table, B by C, using the formula, this one. So, in finding this one, summation of B squared in B by C, same as the earlier, you just need to square this and add. So, this, the summation of this and the summation of this, summation of these two. Now, we have the answer, 4,673 over 3 times 2. N is 3, our A is 2, equals to 6. So 4,673 over 6. We have now 778.83 minus the values of this one plus the value of CX. So the values of this one, we already completed it earlier. So it's a SSB by C now is equals to 1.14. Now we go to find our sum of squares within group of gender and composition in table A by C using the formula, this one. Summation of C squared in A by C, we just need to add the summation of the C squareds. And now we have 7,004 over N is 3, B is 3, so 3 times 3 is 9. So in this case, 7,004 divided by 9, we have 778.22 minus the values of this one, already mentioned in the previous formulas. We just need to find it. So now we have these values plus our CX is equals to 625. Now our sum of squares within the group of our A by C, we have 0.11. Now, in finding the sum of squares within the group of gender, the exercise program, and the body composition in table A by B by C, we use this formula. So, we already encountered this formula. So, in finding this one, we need to just add the summations of the squared of these values of in group. 5 squared, 25, like that. Now we have the total of, these 4, we have total of 2,379 over our N is 3. So we have 793. So that's the values of these 3, as I already mentioned many times, the values are there earlier in the formulas. So the previous equations, I mean. So we have this one, this is the value of this, value of this, value of this, value of this is this, and the value of CX is this. So minus, plus, and minus the CX. We have now the sum of squares within group of A by B by C equals to 4.64. Now we find our sum of squares of total using the formula SS total is equals to summation of x squared minus CX. So summation of x squared, we just need to square the original data, and that is our summation of x squared of our first sub. So now here, this is 2, this is 3, this is 4. Sorry for the typo. So now we have 9 plus 4 plus this, and this is the summation. So the summation of these 4 summations, we have now 876 minus our CX, right, is 625. The SS total now is 251. Now we can use our ANOVA table in our three-way. As already mentioned, with the source, this one, we do have the A, B, C, the AB, BC, AC, A by B by C, and the residual and the total. So, we already find the summations, right? Earlier, we did the equations. Just need to put it here. So, find the residual sum of squares of error using the formula SS error is equals to SS total minus the SSA minus SSB, SSC minus SSA by B minus SSB by C minus SSA by C minus SSA by B by C. So, just put the values here. Excuse me. And minus them all to the total, 251. Now we have our SS error or the residual, 83. Now in finding our degrees of freedom, have the same as we did earlier. We just need to find the df total by n minus 1. In this case, we also have 36 minus 1. We have 35 as our df. Our dfa, a minus 1, we have 2, right? Minus 1 is equals to 1. Our b, we have 3 minus 1 equals to 2. Our c, we have 2 minus 1, we have 1. So let's put it there, 1, 2, 1. Now in finding the degrees of freedom in A by B, just need to multiply the df's of our A and B, as I mentioned earlier. 1 times 2, 2. Our B, okay, B times C, 2 times 1 equals to 2. A by B, A times C, df's of A and C equals to 1 by 1 times 1 equals to 1. Now, in finding the A by B by C, you just need to multiply these 3. A, df's of A, the df of B, and C. So, we have 1, 2 times 1, we have 2 as our df. Now, in df residual, we have the value of A, the value of B, and C. 2, 3, 2. This is the value of A, B, and C. Multiplied to the n minus 1. So our n, right, is 3. So 3 minus 1 is 2. So 2 times 3 times 2, this is our ABC. We have 12 times 2, we have 24 as our residual. Next, finding the mean of sum of squares, or the MS. So we just need to divide our SS to its df. So SSA over dFA. So n over 1 over 1, we have our MSA equals to 1. So 0.58 divided 2, we have this divide, this divide, this divide, this, and divide this, divide into the 2, divide this to the 24, and we have 3.46, and this is our equations. And now we have our MS, or mean of sum of squares. Next, let's find our F ratio statistic. The mean of sum of treatments over the mean of sum of errors, or the residual. So our residual, the df or residual is 24. The MS of our residual is 3.46. So our denominator here is 3.46. There. So just need to divide this, our value of MS, to the value of our residual. So 1 divided by 3.46. We have 0.29 as our F ratio. So we just need to do that. Divide this one, divide this one, divide this one, divide this one, and we have this F ratios. Now, let's find the tabular value of F. So, with the help of our table F here. df denominator, which is the residual, the 24, as always. This is the denominator of our tabular F. Now, the df numerator is its df of the sources. So, we have A in 1, our B is 2, our C is 1, our A by B is 2, and so on. Now, let's find their values. So F1 and 24, 1, 24, we have 4.26. So our value here in our FA, the tabular or the F critical is 4.26. In FB, we have table F to 24. So 2 and 24, we have 3.40. So this is our value in our F critical value. FC, same as this one, so we just need to copy this one. Also this one, we have the same. This one, the same with the FA. And this one is the same with this. So 3.40, 3.40. And that's our F critical value. So let's compare the F ratio statistic or the computed value to the value of our table F. FA now is 0.29. This one, 0.29. So let's put the values of our F ratios to compare them. Next, as you've noticed, our FA is less than our table F, 124. Same as our FB. However, in FC, our F ratio in our FC is greater than its tabular F. In F by A by C, it is lesser. And this 3.2 is lesser. This one, less than its table F, it is less than its table F. So in this case, as this F cal is greater than our F critical, we fail to reject our null hypothesis. So in this case, we have these values, these sources, FA, FB, FA by B, FB by C, FA by C, and FA by B by C is less than our critical. So these values are these things are we fail to reject our null hypothesis. So therefore, a three-way interaction effect does not exist between the type of exercise program, the gender, and body composition in explaining marathon running performance. However, our FC, which is our body composition, that is greater than our F critical, this is greater than our F critical, we reject our null hypothesis. So therefore, in this case, the body composition have significant effect to the marathon running performance. So that's the three-way ANOVA, how to solve the three-way ANOVA in finding the significance and their differences. And that is the analysis of variance or ANOVA, which has the three types, the one-way, the two-way, and the three-way. One-way which only has the one factor, the two-way which have two factors, and the three-way which have more factors. And that's all. Thank you.